ligaments. Is that okay? While the other ones, for you to move, it is facilitated by the presence of the muscles. Muscles bring about movement. Ligaments attach bone to bone. There's also something else that you call tendons. Do you remember tendon?
Yeah.
Mm-hmm.
Um, they're the ones that join the skeleton muscle to the bone.
Mm-hmm. Yes. So these ones now connect. So muscles join organ to bone to bring about movement. Now these muscles are held in position by other small structures that we call tendons. And now we say ligaments now join bone to bone. Mhm. I think we are okay now up to that point.
Yeah.
Okay.
Yes.
So coracoid process also attaches itself to the site of the muscle. I want us to skip this one because it sounds like a repetition. The coracoid process also. I want us to move even further here. Yes, let us look at here. I don't know. I don't know whether that one was a bit faster.
A bit.
Okay. Yeah, I was able to see that. So first, before we go now to these bones, I would like to ask whether you are able to get the difference between the two processes that we have mentioned. That is the olecranon process. We have already mentioned that olecranion, and the other one that we have just mentioned about the coracoid process. Coracoid process tumesema ndio inazuia bone to move to go. Let me just a bit that this one it locks it looks like a hook. Okay.
Yes.
Yeah, and also the other one that we call the ocramion process here. So in brief, the two processes are confusing, mostly to a learner, but one looks like a hook, another one looks like a curved one, so that it prevents flipping of the bone. It's at this point here, so that it prevents flipping with the bone to make sure that it does not move into position. Yani mkono is held into position always without any moving away from that part there. So I'm trying to move. So now we have what we already mentioned sometimes. We said about the upper limb and we talked about the forelimb and the lower limb and the hind limb. Sorry, forelimb we said in mkono, hind limb we said in miguu, and the other part. We already said the various bones that are found on the hand. That is the the humerus, and we also said
Yes.
it has the radius and the ulna. So the adaptation of the humerus, I don't know whether there is much that we need to mention. I will also want you to go and be able to study on the parts, the various parts of the humerus, like the head of the humerus, the shaft, not so many, and then we have the two parts that we have at the bottom here, the various parts that we have at the bottom here, the coronoid fossa, what we call the condyles at the bottom here. But let us just follow in a bit so that we can be able to understand still something on that. I don't know whether that's a bit faster so that I can maybe we can maybe mention something on that.
Yes.
Okay, so that is that what you're talking about, the humerus, and then you can see the very many parts. What is important? The head of the humerus, the shaft of the humerus, and then the lower part. I don't know whether this one is able to illustrate on the same. The head is at the one that we were able to see at the top part here. I hope you can be able to see my cursor at the top here.
Yeah.
And then we have the shaft. From this part to this part is the shaft of humerus. And then we have like a curved part here that we call the radial groove. The radial groove. And then moving down, we have other important parts here that we can be able to see. And that is why I want us to also see, and then how the other bones are able to enter into that part. Yes, let me just share something different for a minute so that we are able to get it even better. It is very, very important not to forget anything about the humerus. And if you are able to understand about the humerus, and then it becomes easy for you even to be able to understand anything more about even the other part of the femur, because they're almost the same. They almost have the same characteristics and the almost similar adaptation, only for different bones that comes in here. Yes, we have this one now here that we can be able to see now. It has there is this view. You can see the head of the humerus,
Yes.
and then it has what you call greater tuberosity. Hapa ni pale tulisema ina lock pale juu kwa kwa olecromion process, and then iko na hapa groove. Anything that we call a groove ni kama cave ama depression ama opening ambayo the muscles will be attached here. And then at the bottom, there is what we call the lesser tuberosity. Now this one will also lock from the bottom now. If I just, yes, let's just use this one. And then the shaft. We already talked about the shaft, the very tall one at the bottom. And then we have something at the bottom here that we call trochlea ama trochlea. This one is now where the radius enters in and then locks. It is the one that it is like a lock that prevents you to move your hand up to, you can only move your hand straight up to 180 degrees. You cannot move your hand further down at the elbow. But at your shoulder you can move round because this one has a head, and then it will fit in, and then it can move round and round and round. But here it can only move up to a certain degree. And then we already talked about the deltoid ridge, the one that appears like curved. You can be able to see it at this part here. Is it okay?
Yes.
Yeah, those are the basic part of the humerus. Lesser tuberosity, greater tuberosity, head of the humerus, deltoid ridge, the shaft, and the trochlea or the trochlea, all on that one. I don't know whether we can mention something about the adaptation of the humerus, and then we can move a bit faster.
Okay.
At the proximal end, it has what we call a large and broad rounded head. That is the head of the humerus. This one articulates with the glenoid cavity. Can you remember where we have the glenoid cavity?
Yes.
Where, maybe?
It's located at the below the head.
Okay. The glenoid cavity pula pale mwisho iko na curve
near the head and the part for the circuit.
Yes, where we if you can remember where we talked about the scapula here. This is the scapula. Yeah. And then we got the glenoid cavity at this part here. Now you see?
Yes.
Yes, for the attachment of that. That is its function. So the head of the humerus enters and fits into the glenoid cavity of the scapula. And then it has a long shaft. That one, the function of the shaft is for attachment of muscles, and also for the attachment of other ligaments to bring about movement, to attach bone to bone. The head of humerus is covered with cartilage. That one is for to reduce friction. Cartilage is like a soft bone. When we are eating meat and then some bones are very easy, you can even be able to chew part of a bone. The very soft part of a bone that we can be able to chew, or that appears like a flour, is the one that we call the cartilage. The soft part of the bone is known as cartilage. This one function prevents the bone from wearing out. That is to reduce friction of the bone. Near the head, there is a rough surface called tuberosity. The greater and the lesser tuberosity function to provide surface area for the attachment of muscles. And then there is kitu ambayo tumesema inaitwa bicipital groove. I don't know whether it's better that you would be having this diagram so that this note, so that you could be following in even from your side. We have the bicipital groove here between the greater tuberosity and the head. this part here is known as the bicipital groove. Bicipital groove, its function, we are here. This one is for the attachment of tendons. So we already said the functions of tendons and for the attachment of bicep muscles. And almost finally, we have the what we call the condyles. Condyles are like is like it's almost like a process, and this one they bring about ni kama vitu ambazo zimefura like projections. Yes, they articulate with the sigmoid notch. We already said about the sigmoid notch pale juu for the articulation or for the movement of the radius and the ulna. Yeah, let me just move a bit here. I don't know whether in our diagram we have it, but it was there where we talked about it. They are here. They're just below here. It's only that they have not been labeled here. They bring about that movement of.
Is that a gap?
Yeah. Now let me zoom so that we can be able to see it. Before you get to the trochlea, from the shaft, the trochlea looks like it has been attached to the both ends of the shaft, where now in between they appear like there is a depression, not completely a hole, a complete hole, like just a depression, where now the radius will come and fit in here. Let me show you the diagram of the radius and then see where it comes and fits directly. This one here, it will come and fit. It will come and fit at this part. You see hapa itakuja sasa hiyo ka space ambayo tumeona pale, ndio sasa hii itakuja zilock in between here.
Okay.
Yeah, and then it becomes easy for the two to be attached. And then finally, point number 7, between the condyles, the one that we have talked about, that condyle, like a small opening, there's another opening, now that small bone that appears to the most end, the trochlea, it is the one that now locks the humerus here completely. This one here at the bottom, it is the one that now ensures that you cannot move your hand up, and you can only move up and down, and then no further movement is possible in that area. It is now the one that brings about the elbow movement. That is the trochlea, a small bone that closes that part on that. Any question?
No.
You can take a screenshot of the adaptations and then you can be able to check them out later.
Okay.
You're good, now we don't have much to mention about the ulna and the radius, but I want to check out on our video that we were seeing and then see whether there is something more that we can be able to grasp on the same. So allow me to share, and then we in a summary on that, and then you can now be able to see that this is at the elbow where the humerus now comes and ends. You can see that, yeah.
Yes.
And then now our two bones, the radius and the ulna, where now from the other side, it is now from the other side here where we have the groove at the bottom there. Now we have the trochlea, the small bone here. Now we have the elbow, and then we have the capitulum. Okay, we shall be able to understand that. Let's just follow in, and then it will be easier for us to understand something. Yes, you can see now that opening that we said here. It's at
Yeah.
this region. We said there are two of them. Where now it will fit exactly in that one. Maybe we can also mention something on that. This is the ulna or the ulnar bone, as most people pronounce them. When your hand is not covered from outside, when when you close your arm or when you lift your hand up, there is a bone that appears to be projected and very very sharp pale kwa elbow. I'm sure you have been able to experience that. Are you there?
Yes.
Mhm. That small bone at the bottom of your elbow, the one that you can even, it is even visible. Okay, when you move your arm up and down, there is that small bone that appears hapo chini kwa elbow. That is the olecranon process, and it is at the end of the ulnar bone. Okay.
Yes.
Okay. Something more. I hope you can also be able to see where we have hapa juu tumesema kuna, I'm just trying to move a bit back. Juu kuna olecranon process juu,
Yeah.
then at the bottom we have the other process here. Okay, I don't know whether they got lost. Yes, olecranon process at the top here, then the coracoid process at the bottom here, and then we have the notch. Notch simply means, okay, I'm zooming so much. Notch means like a pouch or like a cave here, like a cave here. So we have one process at the bottom, another process at the top. The olecranion process, the coracoid process at the bottom. Is that okay?
Yes.
Yes. I hope we are trying to get something.
Yeah.
Okay. So generally, what we are trying to understand here, the video is adding more points that maybe are not necessary to our understanding. But really, I wanted to illustrate where these bones are and what are their functions sometimes. Now, these are the two bones. These are the ulna and the radius are two curved bones found on the lower arm. Found on the lower arm, and then they are found between the elbow and the wrist. Wrist, we say, is where we wear our bangles, our watches, and such. That is the wrist. Elbow is at the top, and then you can be able to see the two bones here. And
Yes.
distinctly, what you told us in the introduction of the lesson, you said that the radius articulates. It's found on the thumb, ama kidole gumba. I don't know whether that is the correct name of that finger.
Yeah.
And then we have the ulna on the small finger. And then you can see what we were seeing on the video, the two bones here. It has something that we can be able to mention. We said that the radius appears to be thick, while the ulna is thin but taller. Okay. Ulna
Yes.
thin but taller. Radius wide or thicker and shorter. That is very very important. Again, ulna iko na hii kashimo ambako kako hapa ambayo inaitwa the sigmoid notch. Sigmoid notch. We have already talked about the olecranon process, and we said a process is like a bone that is projected outwards, like that. Then we have the cartilage on the most outer part on this side, and then the ulna taller, and then with a sigmoid notch, olecranon process, and pale side ingine kuna kamfupa kengine kametokea ambako tumeita the olecranon. That is the olecranon process, and the other one we called it what? You can remember?
The the coron.
The coracoid.
Yeah, coracoid.
Coracoid process. Thank you. So with that now, I think now it is possible for, okay, yes, you can be, I want you now to check out later on yourself about the adaptation of the ulna and the radius. That is, it has from point number 1, point number 2, going up to point number 4. I don't know whether you are able to get a screenshot on that. In the first two.
Yes.
You got it? The first two here?
Yeah.
Okay. And also on the other two, on the other number 3 and 4 at the bottom, at the top here. It is that one does not have so much. Anything that I am always telling you to check out later is the one that is easy to comprehend, even without so much explanation. And because of that is, remember we are moving at on time, so we can take a lot of time in one area. Any question?
No.
We also talked about the bones of the hand. This one I already explained last time about the carpus, metacarpus, and the phalanges. So we said carpus are found on the wrist, metacarpus are found on the arm, carpus, the phalanges are the fingers. Is it? Yes. And then the on the wrist there is what we call the gliding joint, together with the palm, or the yes, that is the palm, that is the correct name. Fingers have what we call a hinge joint, they join together. I hope we shall get time and check out on that. Now, having talked about all that, from when we started we have talked about the hand from the scapula. It is now not difficult now for you to check out on the legs because they have no major difference. The only difference is what we mentioned. Kwa mkono inaitwa humerus, kwa mguu inaitwa femur. It also has the shaft, it has the head, it has all that. Even the other adaptation, the only difference is the names given to that one. I don't know whether you'll have a problem in checking out on the same.
No.
Okay. Oh, the only thing maybe you can do is to get again this screenshot here about the adaptation of the femur. I've given so much adaptations. It is important you check them out. I think it's visible.
Yes.
Okay. And then we talked about the knee. We said a very small bone is called the patella. Good thing is that we had mentioned about this, and then it has various functions, provides a site for muscle attachment, and then makes the knee joint flexible. It also prevents overstretching of the hind limb at the joint. You can also vile, how you can move your hand up to 180 degrees at the elbow. The same, you can move your leg up to straight when you are standing straight up to 180 degrees also at the knee. So it is important you will be able to check out on that unless you have a question. So you can also be able to check out on the tibia and fibula, ziko related. You can also see the tibia is also thicker, appears to be thicker here. I'm trying to zoom in, appears to be thicker here and shorter, while this one appears to be thinner and taller. Okay. You'll be able to check out that, or you have any question, any problem we can mention. I'm sure you can do that. Is it?
Yes.
Can we mention something about the joints now? If that's okay?
Yeah.
Okay. Joint. From the word joint is to bring together, to come together. Anything that joins anything. I'm using the same word to describe joint. A joint is any I don't want again to use the word joint. Any connection between two bones. It's any connection between two bones. I would like you to read this today. You have not read something. We have had a lot of explanation. Maybe you can start here.
At the joint, a bone is connected to another bone by inelastic tissue called ligament.
Yes. What is a ligament? A ligament is an inelastic tissue that joins bone to bone. Should I repeat that?
Yes.
Yes. So what is a ligament? A ligament is an inelastic tissue that joins bone to bone. So that is what we mean by a ligament. It joins one bone to another. Is known as a ligament. Now we also have something different called a tendon. You can also read for us this one here.
At the joint, a muscle is connected to the bone by inelastic tissue called tendon.
Tendon. So what is a tendon? A tendon is an inelastic tissue that joins bone to joint. No, that joins bone to muscle. Okay, can I repeat that?
Yes.
A tendon is an inelastic tissue that joins bone to muscle, from one bone to muscle. Tendon, from one bone to another bone. Ligament. Similar characteristic to the two, they are both in elastic tissue. What do we mean by being inelastic? Inelastic simply means they do not stretch. They do not stretch. They remain the same size together with no stretching. So they are both inelastic.
Okay.
Yeah, then we have types of joints. We have types of joints, what we call fixed or immovable joint. We have what we call gliding joint. We have what we call pivot joint. And the last one, we have what we call movable joints. But we shall also be able to understand even better. When we started talking about the skull, we said that the bones of the skull are fused together by a joint that we gave a name. Can you remember the joint that we gave a name? The name of the joint that we said is found on in the skull.
The one that's connecting to the neck.
No. When we talked about the structure of the skull, we said it has the jaws, it has
Yeah.
the nasal cavity, it has they have a very many organs, it encloses the brain, and we said the bones of the skull are fused together by
Oh,
special joints called
the sutures.
the sutures. That's okay.
Sutures.
Yes.
Yeah.
So the sutures is an example of an immovable joint. We also talked about the pelvic girdle, that is the sacrum. Sacrum, we said the bones are completely fused together. So that is where we find also an immovable joint. Gliding joint, another example. To glide means to move on top of each other, to move on top of each other, to glide, to move. When you touch your palm or your wrist, hapo mahali where we wear the bangles and the watch and such, when you'll feel like there are bones moving on top of each other. Is that right?
Yes.
When the bones feel like they are moving on top each other, then we say they are gliding. So an example of a gliding joint is at the wrist. At the wrist.
Yeah.
And then we can also talk about the pivot joint. Pivot joint means to hold into position without falling. Something that is on the top is taller than the one that is at the bottom. Like, for example, the whole head is put together or is held together by the atlas. Atlas is a very small bone, but it is holding the whole head. That is a pivot joint. And finally, we have what we call the movable joints. We have various examples. One example is what we call the ball and socket joint. Another one is what we call the hinge joint. And the other one is joints at the fingers. Movable, opposite of immovable. It means the bones now can move differently. They can now be able to move from, for example, you can be able to close your hand and then the fingers will lie on the bottom. You can be able to stretch your fingers and such. So that is to bring about movement. So ball and socket joint. Another one is hinge joint, a very important part also when you talk about the joints of the skeleton. Two functions of a joint. Maybe before we can check on something, you can maybe read for us the two functions.
Allows movement to occur between the bones. Some joints allow passage of blood vessels and nerves.
Yes. Joint to allow movement between two bones. To allow passage of blood vessels. Remember where we talked about the vertebral canals, where they allow blood to flow in to bring up for the supply of nutrients and also for the supply of oxygen, and also for removal of waste that comes in. When you talk about also joints, most of these joints, we talk of joints that are dry and joints that are lubricated, or joints that have fluids. Joints that have fluids are known as synovial joints. I don't know whether we are moving a bit faster, but I hope we are able to understand these points one by one.
Yes.
What are synovial joints? Synovial joints, they allow some considerable degree of movement. Considerable, what we say, when we talk about considerable, we say the movement can be felt or it can be seen. That's why we call them synovial. And their main characteristic is that the head of these bones is covered by cartilage. Can you remember we mentioned about cartilage? Like on the head of the humerus.
Yeah.
On the head of the humerus, on the head of the radius, on the head of the femur, there is cartilage. Cartilage, we said, is a soft bone. For example, in this diagram here, you can be able to see the articular cartilage, a very thin part here that looks like a very soft bone. It prevents wearing out of the other bone now. The small thin area here, it will prevent the wearing out of the other bone. They also have what we call synovial fluid. Synovial fluid. Synovial fluid. I don't know whether this is practical from your side. When we are slaughtering, or I don't know whether you have been present when an animal is being slaughtered into small pieces.
Yes.
I know girls fear to see an animal being slaughtered. But
Yeah, sometimes.
yes, but when the animal, when it's being broken into small pieces, you, for example, when they are separating nyama ya muguu hata kwa kuku, when they break it, it appears like the bones are wet. They're not completely dry between each other.
Yes.
That wet substance, especially on the shoulder, especially on the legs, is the one that we call the synovial fluid. What are the functions of the synovial fluid? Let me try to see whether it's mentioned on top of. Okay. I don't know whether where they have mentioned that. So the function that fluid, but I am sure now you've been able to understand what we mean by the synovial fluid.
Yes.
The function of this synovial fluid is good. There's a diagram here. Hapa ni kwa mguu, kwa the tibia and fibula here. This is the knee. This is the patella. You can see the patella here. And then you can see the synovial fluid here that goes up to inside. And it has very many functions. One, it helps to reduce friction in wearing out of the bones when they are moving on top of each other. It also allows it also, let me try to understand that the function of the synovial fluid is to it absorbs friction. That is one of something that I can be able to remember. So it reduces friction. Another one, it also it is the one that is rich in supply of nutrients, because a fluid is like the blood plasma. It supplies nutrients to the bones to nourish, what we say, to nourish the bones. It also acts as shock absorber. Maybe when you are jumping, when you are clapping, when you are carrying something that is very heavy, when you fall, it will absorb the shock, and then it prevents the waves or the shock from flowing to other bones. So it is important, go and check out on what are the functions of the synovial fluid, but generally to reduce friction, to supply nutrients, and also to act as shock absorber. Is it okay?
Yes.
but it is important you can also be able to check out on that maybe even later on time. Mm-hmm. You have a question?
No.
Mm-hmm. Now, another very, very important component of joint is parts of a synovial joint. What are the very many parts that are involved in a synovial joint? We have various of them. We have a synovial joint has a bone or has bones. Remember, two bones are coming together. It also have ligament. Function of ligament, we already said, for attachment of bone to bone. Cartilage, we said, when you go back to the structure of the humerus, we said the head of the humerus has a very soft material that we call cartilage that has two main functions: to act as shock absorber and also to reduce friction during movement. It also has the synovial membrane. A membrane is like a skin that covers the bone and between the two bones that will the function of the synovial membrane is to secrete and to enclose the synovial fluid. So the synovial membrane secretes. What do we mean by to secrete? To secrete simply means to produce and to transport. To produce and to transport. That's what we mean by to secrete. It produces and transports the synovial fluid, and then it is the one that encloses the synovial fluid. Haishi, we are always, or the synovial fluid is we are born with it, especially hapa kwa knee. It is there even in our old age. That is why we are able even to walk, always even in our old age. And then the synovial joint also has a tendon. The tendon, function of the tendon, we already said, is to connect a muscle to a bone. And then we have the synovial fluid. We have this function. Yes, this is what I was looking for. I request you to read out for us the functions of the synovial fluid.
It nourishes the tissue or the supplies or supplies oxygen and nutrients, lubricates the joint, acts as a shock absorber, reduces friction, and distributes pressure at the joint.
Yes, thank you. So, functions of the synovial fluid: nourishes the tissue. What do we mean by to nourish? To nourish is to ensure that it is alive. Being alive means it is fresh, meaning there is food, there is water, and there is oxygen. That is what we mean by to nourish. To lubricate the joint, the fluid is liquid. It lubricates. It is like now the oil to ensure that there is no wearing out. Shock absorber to ensure that the other bones does not break easily. To reduce, it reduces the friction and it distributes pressure at the joint. Yeah, when the impact is so high, it will not affect all the bones. Maybe it will only affect one bone, and then to ensure that that pressure is not, the impact, it does not break the other bones. You can also take a screenshot about the components of a synovial joint. It's a very important part that you can be able to check out later. Mhm.
Yeah.
Yeah, good. I so far so good. You remember we
Yes.
also mentioned about movable joints. There are two examples: ball and socket joint. Another one is known as the hinge joint. Something some learners have a problem differentiating ball and socket, hinge joint. For example, let's start with ball and socket. Generally, where do you think we can find a ball and socket joint?
Where there's movement, there's usual movement at the
Okay.
where bones have to move.
Where bones have to move. Now, my question is examples of places where you think we can find this one, ball and socket. It is very clear from the word.
At the knee,
Mm-hmm.
the shoulder,
Mm-hmm.
the uh, elbow.
The elbow. Yes.
Yeah.
Okay. Now, um, we said now let's go back where we talked about the humerus. The humerus has a ball or the head of the humerus. You remember where we said about the head of the humerus?
Yeah.
The head of the humerus is the ball. Okay.
Yes.
And then where the head of the humerus enters, that is the socket. Very easy. The ball and socket joint brings about a movement of 360 degrees. Where can you move your body 360 degrees? That is appendicular skeleton. One is at the shoulder. Is it? You can be able to move your hand round.
Yeah.
Another one is your leg. You can be able to move your hand front, backward, and sideways. That is 360 degrees. That is a ball and socket joint. You got that?
Yes.
On
So
the
the
yes. Mhm.
so the elbow is not included.
Yes, the elbow and the knee are not included. Here is only at the shoulder and at the hip.
Okay.
Yeah. Then we have, if you can remember from what I illustrated when we said about the ulna and the radius, we said iko na sigmoid notch, has a notch. Okay. And then when you move your elbow, it closes so that you cannot stretch further up to only 180 degrees. It can't go beyond that. That is now a hinge. What do we mean by a hinge? For example, mlango. Mlango, mlango ya nyumba. Are you now trying to get this, what I want to mean? Or the window.
Yes.
When you open the window, it can only open from outside. When you close, it reaches a point that they cannot move beyond that point. Is that correct?
Yeah.
Because the things that join the door at the top and the bottom, we put things that we call hinges. So they only allow movement up to when the door is straight or the window is very straight. Now you can relate that.
Yeah.
Yeah. So
Yes.
yes. Like this one now here. So the hinge, I just want us to move direct. So we have the hinge joint, hinge. Kindly, you can read through for us.
In this type, one bone has a depression and the other one has smooth condyles that feed and articulates in the depression.
Yes.
It allows movement in one direction or plane or through 180 degrees.
Yes. Vile tumesema iko na depression, it just enters and then it is locked. It allows movement in one direction up to 180 degrees. Examples at the elbow, at the knee. That one and also at the joint between the phalanges, kwa vidole. When you can only be able to close your fingers to the arm or to the palm, but you cannot stretch them beyond when they are straight, your fingers. Is that correct?
Yeah.
Movement up to a certain degrees of up to 180 degrees found between the humerus, ulna and radius, found between femur and tibia, and also at the phalanges. Phalanges ni kwa vidole za mguu na pia vidole za mkono, all of them are phalanges. Now, that's an example. You can see it is enclosed here. It cannot go beyond this part here. This one can only stretch downwards, but up to that angle, can't go round like where we have the other one. Now, I don't think there is much to explain on that. It's clear, is it?
Mm.
Yeah, and then we have the ball and socket joint. You could also read for us that one.
In this type, one has a rounded head and the other has a cavity or socket into which the head fits or articulates. It
Yes.
allows movement in all directions, planes, or through 360 degrees.
So this one has a rounded head, and the other one has a cavity. Head of humerus, head of femur. So it will bring about the movement that is in the hip region and also in the shoulder region. So what is the difference between ball and socket joint and hinge joint? What difference can you be able to, does it come out on that?
Um, well, in my opinion, the
Mhm.
difference it moves. Okay, the hinge joint moves. It allows movement in 180 degrees,
Mhm.
and the other one allows movement in 360 degrees.
Mhm. Any other? That's very correct. Any other difference that maybe you have been able to identify?
Um, yeah, that's what I can remember.
Okay. We also said one has a depression. If I just go back here, one has a rounded head while the other one has a socket.
Yeah.
And the other one we said one sorry, one has a depression and the other has smooth condyles. All what do we mean? Yes, one has a depression, the groove. Remember we talked about the groove, and the other one has what we call condyles. All how can we say this? The bone is curved. It fits into the depression. It enters into the depression to bring about a movement. So one, it's simple to remember. One has a depression or a curve. Another one has smooth condyles. It's not difficult for you to remember that. I think it's important we can end our lesson at that. We have had time. We have finished about appendicular skeleton. We have also talked about the joints that we have. I think it will be good that we can be able to get up to that point, unless you have a question.
No.
Okay. So I would also request you to study more hard, do more research on the same. I am sure we have been able to at least make some improvement on so far as that one is concerned.
Yes.
Yes. I want to thank you for being here for that long time. That's an hour and a half. It's a long time to follow that. But good thing is that we always make impact when we have a lesson. So I want to wish you a good day, study more harder, and I'm sure you are going to achieve the whatever that you wish to achieve in your biology studies.
Yes, thank you.
Thank you and have a good day.
You too.